Right. So good afternoon, everyone. My name is Iyad. I really want to thank you all for joining us on this virtual webinar. And I truly hope that you and your beloved ones are doing great and safe and well during this pandemic COVID thing that we all hope should end up soon. So today it's gonna be really a quick tour into data-driven practices, machine learning, with a touch of an AI, and try to just give a brief background about what is artificial intelligence and what does it take to have a data-driven project that delivers. I will discuss briefly some of the examples about the latest significant progress, which shows that this is a serious area that we should all be thinking about embracing in our businesses, regardless of what sector is that business. And then I will touch base on some of the recent challenges. And I have to say, when it comes to machine learning and AI, there is a long list of challenges, but here I will specifically speak about three main challenges that we commonly encounter, in particular when we work with real life projects involving industrial or business partners. And I thought then it would be useful for everyone, even for business people or managers or even researchers and students, to share a case study where we and an industrial partner joined forces, worked in a very challenging problem and delivered what I would call really cutting edge, unique solution, just to show how important that we get together and work on such area, because this is really not a one man or woman show. AI and machine learning is a huge area. It is it's multidisciplinary, so we need all efforts and knowledges together. And finally, I will wrap up with quick conclusive points and some suggestions for future work. Just to put things in context, today I'm just focusing on machine learning. AI, I'm sure you saw a lot of Venn diagrams. So I'll speak specifically about supervised machine learning algorithms. Unsupervised and reinforcement learning are great research areas, and a lot of interesting stuff is happening there. But I thought supervised machine learning is more aligned with the title of the talk today. And to start with, I want to take you back to the old good days where, and we still do this, traditional programming or software development or coding. We often, as you can see in the diagram, we have data and we devise or create some algorithms and program them to produce the desired output. This has happened, and it's happening, and it will continue to happen over and over again. And you could think of this across many domains, but simplest possible example is really the calculator. You have the data, you have to devise, these algorithms and generate the desired output. So traditionally, this is what we are doing, and we will continue to do over and over again. With machine learning, if you watch the diagram, it's slightly different. We have the data and we have the output. And what I want to do here, I want to give the computer the ability to learn without explicitly program or handcraft the rules, as Arthur Samuel put it 60 years ago. So in simple terms, machine learning, we learn from past observation. More data and better quality data certainly leads to better performance. And today you see this changing our practices across so many domains. So that's the simplest idea about machine learning. In practical terms, and if you take an example, a loan application, if I want to work in the traditional way, I could, maybe work with a couple of banking experts and set some rules about who should be getting a loan. So, salary, spendings, household income, etc. And then I will program these rules and get the desired output. That's good, but it's limited. today, because of the massive amount of data, what people are doing, I can go back and look at all the historical information related to the hundreds of thousands of customers who actually took loan and paid these loans, or took loans and defaulted. So I know everything about these guys, their demographic and personal information stored in my data set, and I know if they defaulted or if they paid. So simply using this machine learning algorithm or algorithms, which if you are not from the field, think of it as a magical formula for now, we could find the relation that maps a customer to the potential outcome. And then I will end up having a very accurate solution that will provide loans for people who will very likely pay these loans. In academia, because sometimes we like to complicate things, we represent this in a matrix notation. I know many people don't like this, but think about these matrices. Each row here is representing really a customer, and the Y's represent a final outcome. And what we want to do is we want to find the relation to map the input to the output. And this simplification of the story, you could think about it about anything. This data set could be large volumes of videos, and your solution you want, or your objective, you want to detect and track human movement, you know, or you want to detect a defect in one of the equipments in your installation, or cracks, or you know, abnormalities in a sensor performance, etc. So that's the whole idea in a very simple terms around machine learning. In practical terms, and perhaps these looks very obvious and intuitive, but you would be surprised how sometimes we miss things. The key important part of the story is we want to define a clear problem. I want a solution to approve loans applicants accurately, because, you know, I'm not happy with the current, you know, defaults I have in my bank. The next step is I want to have and look how much data I have, you know, and there's a lot of data preparation and pre-processing and technical stuff that perhaps goes beyond the scope of this project. And sometimes the data is not necessarily the data that you have in your business, but you might be interested in crawling the data on Twitter that mention your product, you know, to also feed it and enrich your decision-making process. Now, I have to say that this data preparation process perhaps is 60 to 70% of the whole story. And what follows then is, think of it as this magical formula or black box or whatever you can call it. We want to train these machine learning algorithms and validate the results. And there is all sort of, you know, technical stuff that happens there. And finally, if I'm happy with the results, I want to deploy the solution. And often we underestimate the importance of monitoring the performance of your AI solution. And there's two ways of monitoring this. One of them is simply by, you know, having some functional features to automate the process. But I believe that the domain expert should always be there to have a look, because as I said, we are working across different disciplines. So this is somehow a very high level overview of really a successful, if you like, data-driven application that, you know, could potentially change the game of your business. The two key things that I will focus on today in this pipeline are the data and the models. And clearly the easiest part is the data. Data is everywhere today, and a lot of it is available in the public domain, and you could use it for your own use. Interestingly, if you read this white paper, they are saying that by 2025, in 5 years' time, we will end up having 175 zettabyte of data. Now, 1 zettabyte equal 1 billion terabyte. So if your laptop has a good hard drive of 1 terabyte, this is equivalent to 1 billion hard drive. Now, those who work with floppy disks like me in the old good days they can imagine the significant progress in this. Interestingly, also China would grow its data sphere according to the same report by 30%. And it is projected that, you know, in 10 years' time, AI will add 16 trillion to the global GDP. Half of this almost will go to China and the other half will go to the US, followed by Europe. Now, what I wanted really to say from this is data is a game changer. And in order to stay in competition in the coming few years, you really have to consider moving to more toward, as I like to call it, data-driven, intelligent utilization of your data. And by the way, you don't have to have gigabytes of terabytes of data to start this. Sometimes, you know, with minimum amount of data, you could still do something with it. So the data is already there. And the algorithms, I'm not gonna bother you about the details of you know, the techniques here, but I just wanted to say that there is probably around 200 different machine learning algorithms. You could start with linear regression and move all the way up to deep neural network. And if you don't want to bother about these, I like to think about them as mathematically accurate models. They were tested and proved to be working. And I kind of argue that when things fall apart, I really don't blame the algorithms. I either blame, you know, the data or who applied it or the way it was applied it. I have to say also in this respect that deep learning, maybe in the last 15 years, have made significant change, you know, and you see things related to image analysis, image generation, voice recognition, chatbots. It is already changing the way we are doing things. So this is, so you have the data, you have very well established set of algorithms. And I thought about this, you have the tools and the technologies, and these are open source, available, coupled with all kind of learning resources, such as free books, videos, code available over there. Even if I added this here, papers of code, the latest and the cutting edge research in this area is published with the code online. So there is a huge chance to learn and apply things in your own business or in your own domain. Just a quick example, this is on a GitHub. You could go and download the code. It's just 150 lines of Python code will allow you to run one of the most interesting AI advances in recent years called GANs to generate faces like this and then control the style of these faces, you know, in a very intuitive way. So the tools are there and the knowledge is there. And of course, the computing power is there. I mean, although hardware is getting cheaper and cheaper for large experiments, sometimes we need like supercomputers. For instance, here at the School of Computing, we heavily rely on machines like the DGX-1, where we could run experiments including hundreds of millions of images per day. But still, in your laptop, you will be surprised how much you could still do with that. So all the building components to build a successful data-driven AI machine learning solution are actually there and accessible almost to everyone. And if you look just at the recent stories, if you put the data and the AI and the computing power together, the result is significant, exponential, and predictable progress. And I just highlighted the predictable word. You might be interested in reading more about this for Ray Kurzweil, who speaks about time when robots will take over and exterminate us, but perhaps this is beyond the scope of this talk. So you can probably look at this later on, but there are serious things happening in this domain. Just to give you an idea, computer vision was always one of the biggest challenges for the AI community and the machine learning communities. And when I say computer vision, it's simply to teach computers to recognize things in images, like let the computer check if there is a ship or a dog or a cat in a certain image. And this has great, applications across the oil and gas sector, the medical domain for medical images, the health, security, you name it. But if you look at this bar plot, in 2010, the error with these algorithms was almost 30% in recognizing these objects and images or videos. And by 2015, only in 5 years' time, the error dropped down to almost under 5%. Today, as we speak, the computer are outperforming the humans in visual perception. Now, this is for those who work in like research areas related to machine vision, this is significant progress. It's not incremental anymore. It's measured by orders of magnitudes, really. Deep face and face recognition, with the CCTV. Today, we accurately detect and track people movement under different conditions. Facebook released this paper in 2014. They achieved 97% accuracy on face recognition, by computers, if you like, beating the state of the art then by 27%. Now, people who work in the field know that perhaps prior to 2006, you used to get a PhD degree if you push the results by 2 or 3%. So look at the margin and the significant progress in this area. I like always to refer to the AlphaGo because this is really real and true intelligence where, DeepMind algorithm won against Lee Sedol, the champion of Go. This is a very simple Chinese board game. But what's interesting to know here is that the amount of possible combinations of moves is more than the number of atoms on the planet. So therefore, you really need an intelligent solution that could, do this calculation without going through this massive search space. And it was really a breakthrough. And I would highly recommend Google the documentary about this and watch the whole story behind it. Self-driving cars, they are there. I think the technology is there. We have cars equipped with sensors. They are monitoring 360-degree around the car, so I really don't see, I think why we don't see it on the streets very common, it's more about regulations and rules, and perhaps different countries have different policies, etc. But the technology is there. And even with a simple Google search, you could see how much AI and machine learning were used during the COVID-19. Chatbots have been extensively used to answer public questions. A lot of algorithms have been used to forecast and understand the spread of the virus. Advanced techniques have been used to summarize the massive amount of knowledge about this virus to give us better understanding. And in medical image analysis, this is hugely also used. So this is actually touching every aspect of our life in a way. And I would add, other than these reasons to convince you that why we should really move more toward data-driven practices in our lives in general, is I think as humans, we are cognitively biased, and you would be surprised how sometimes we follow our intuitions in taking key decisions. And I would highly recommend, if you are in a decision-making position, maybe to look at Thinking Fast and Slow as one of really very good books that shows how easy we made the mistakes as a human. So all this together, I think we should be moving more toward data-driven practices. The challenges, I will mention here 3 main challenges just for the sake of time. And I won't go through the details of how we address these, but I will refer you to some of the work that we do, and hopefully this will attract some interest as well. I think the first and very obvious challenge is the data accuracy. If my data is not accurate, then whatever AI models you use, it won't work. And we could work with large volumes of text reports to predict a certain event, for example, in the oil and gas industry or medical reports or etc. If we are using the wrong data, we will receive wrong results. And this is the easiest way to compact this, is to have really the domain expertise in the loop. And when I say domain expertise, those people who don't know anything about AI or machine learning, but they are fully aware of the problem, either medicals or engineers or etc. And also, as I like, often called manual error analysis of the results. When we do AI, we tend to automate, the process of training and validation of the solution, but also it's worth looking at some random samples of the outcomes and check where we are going. So data is the most important part of the story. Data authenticity is another story, where today, and due to the significant progress, we can easily manipulate digital content and data. This is, I think, a fight between Mr. Trump and one journalist last year in December, and probably it was the journalist's fault, not Mr. Trump's fault, definitely. But what the White House did after this kind of dialogue, they took the video and they just removed few frames from the videos and they published it on their Twitter account. Now, when you watch the video after being manipulated, the journalist will look as if he was aggressive toward this lady. Well, the truth is not, but it tells you how easy you can manipulate the content to change the whole story of the data, and then whatever AI model you use, it's not gonna give you the right results. It gets more serious and sophisticated with the deep fake news, which I'm sure like you hear about, where you might find yourself saying things you never said or doing things you never did in a YouTube video, for instance. So again, this is a true problem. I mean, there is wide range of techniques to manipulate digital content, and you might want to look at our work in this area. And it is one of the issues that has to be taken into account, how authentic my data is before I aim at utilizing it intelligently. The other problem is, which is again surprising, how common this problem in so many domains, we still get into the trap of biased data and biased results. And just to give you an example, if we are building a mobile application to just recognize cats and dogs, so we have, again, according to our pipeline, we have to collect images of dogs and cats and train our model and report the results and validate it, and then maybe deploy it in a mobile app. But if 95% of your images are cats, then your model will definitely miss the dogs. Very likely, he will recognize most of the cat, but whatever dogs, the poor dogs will be always missed. Now, you cannot accuse AI of being biased against dogs in this story, but it's just the data. And this is happening. This is available, for example, in the oil and gas, 99% of sensory data shows normal behavior. Perhaps 1% shows abnormalities. We need to be able to pick this 1%, so that's existing. The worrying part of the story, which is perhaps beyond the scope of this, if you have people in charge and they have the money and the power and the authority, and they decide to devise a data set that is biased toward against the dogs, okay? So that is probably even more challenging, but that's not really I would say my area of research. This needs power and, authorities to handle such, I would say, intentional bias in the data, which could lead to really bad results in some situations. Again, I won't go into the details, but what I wanted to say here that we do a lot of work just at the data level, re-engineering the data, restructuring it, before actually we reach the stage where we can take a biased data set like this or imbalanced and make it more fairly balanced, you know, at least to ensure non-biased results of whatever machine learning algorithm you used. It could be even more challenging when the data is not only biased toward dogs or toward cats, but some dogs and cats looks very alike, so they are not separable. Again, it's some of the work that we are working on here at the School of Computing, but this is very common, again, across most of the domains that we know. And this problem in the health is very visible problem. If any of you like interested in some of our work, please let us know. We can share more with you. So that's the data bias. The final problem, and I think this is one of the main barriers for the wide adoption of data-driven and deep learning solutions in some industries like the oil and gas and maybe agriculture and food industry, it's a marine industry. It is what I call it data annotation. In the deep learning era and with machine learning, if I want to train my model or a solution to detect and recognize the different types of fish species and perhaps automatically measure them and sort them, which is of a great benefit to any industry, I need to have enough examples that are fully annotated. And I won't bother you with the technical details here to train my model. Now, these data sets are not readily available until today, despite there are some techniques like, you know, few shot learning, zero shot learning, semi-supervised, unsupervised, large, you know, it's perhaps the most common approach right now is still manual. So you need to bring people to manually locate these fishes in the first stage and, you know, label them and annotate them to ensure that we get actually proper results. So again, this is something we started just working with some AI models to generate the content. So we started by, if I don't have enough data, for instance, if I'm doing data augmented digital recognition, handwritten digit recognition, so I could perhaps synthesize more data and then ensure that my model will get better results. So I will start just, so that hopefully give you a brief, quick overview about, you know, key topics related to AI and data-driven application. I'll speak about this case study with one of our partners because I thought this is a good example which shows really how useful it is when we work together from multidisciplinary to solve a particular problem. So this project ran for 2 years between our school at Robert Gordon University and the MVGL. It was funded by the Data Lab Innovation Center and later on by OJEC, Oil and Gas Innovation Center. And the problem was simple. We have large volumes of undigitized engineering drawings like this. Now, clearly, fully automating the process of digitizing these drawings is useful because you can cut the time of interpreting these drawings from maybe 2 hours to under 5 minutes, and it will provide rich source for further data analytics for wide range of applications. When we start looking at the problem, we were surprised again because of some of the challenges I mentioned that despite the significant progress in machine vision, very little work has been done on engineering drawings in general. And you can look at our review paper, which really like go through in details into the problem and some of the existing work. So we start building some solutions and we manage, you know, to transform this dead digital image, if you like, into an Excel sheet that capture everything on this diagram. And again, some of the results are in the public domain, but then we decided we wanted to take this further. with our partners where I want to load the diagram and I want my AI or whatever algorithm we use to fully recognize everything in the diagram and then export it in the required or the desired format. And for that, we use what is like deep learning based approach. But again, it's about collecting, annotating, training, and validating the AI models, and then obviously deploy. And this is very iterative, and I have to give full credit also for Dr. Brian Bain from DMVGL, who's the domain expert here, who was involved with us throughout the process of developing the solution. I'll show you a quick video, and I think maybe our school is the first to produce an end-to-end framework for such really challenging problem. And we are still working on this, and we would like to take it further. So you load the image, you click a button, this will trigger the underlying algorithms as can be seen. And then you will see different types of sensors, reducers, ball valve, etc. You can also extract the text because this is for us another image or object of interest in the image. All these text elements are numbered just for validation and evaluation of the models, but it's basically to extract every single component of this diagram. Similarly for the pipelines and the connectivity information, and there's some other features we added, like selecting just part of the diagram and process it, because as an engineer you might only be interested in one portion of the diagram. Search for an item, we use this mainly for validating the results. We know which item is what, so we want to make sure that if this is detected as a pipeline, it is actually a pipeline. And here where we work closely with our partners to validate all these findings. And of course, the most important part of the story is to export the results. I want to export all this knowledge in the diagram into one CSV file or Excel sheet that can be used then for various applications. Again, this is early version of the work, and even the CSV, we use it here for further validation of the results. But this shows, the quality of such collaborative work with industrial partner. If you really want more technical details about how did we do this, please refer to our paper. And perhaps I should conclude here and wrap up this presentation by saying really the data-driven practices and AI is not a one-off project. We can't wake up in the morning and I will say, you know what, I'm going machine learning approach. It's interdisciplinary. It's a culture that needs to be embraced within the institute. The underlying knowledge of the algorithms and the ability to validate the results and do bias variance analysis and all sorts of this is very crucial. Knowledge of tools and techniques and how to implement them. And the industry, I think they are central part of this story. They have the domain expertise and they have the data. And really academic collaboration with the industry proved to be very useful. I have to say, specifically in Scotland, because I work in Scotland, we were really very lucky because we have a lot of innovation centers, and in particular, I would like to mention the Data Lab Innovation Center, who are really pushing the boundaries and help funding a lot of these collaborative projects with industrial partners. Other funding bodies like, oil and gas, Technology Center, the Oil and Gas Innovation Center, they're all trying to push research in this area by bringing academia and industry together. I would say finally, obviously I am one member of a team of great young men and women at RGU. And, this is a very active area in our school. I only showed part of what we are doing and our school is doing, but you're always welcome to contact us. And I'll stop here. Thank you very much. And most of the details you will find it in my website as well. Thank you.
Thank you very much, Iyad. That was a really interesting presentation. And do you want to take down your slides? No, perfect. I'm sure lots of people have got questions, so just as a reminder, if you want to put any questions that you might have for Iyad into the Q&A function at the bottom of your screens, that would be great. Probably just to get us going, Iyad, I guess as a company, probably listening to you, and I think, the more you read in the media and in the news, it's really important that companies start considering how they become more data-driven.
Mm-hmm.
If you were wanting to start thinking about this, what would be your recommendations of the first steps that a company should take, and does it require a lot of investment?
Well, I really don't think you should start by investing too much. I mean, I think the first step, perhaps, if you don't understand the problem or this whole field of AI, maybe you should speak with academia. I mean, we do this all the time. For example, at School of Computing, we are approached by companies who have like all sorts of problems and data and say, we want to go fully data driven. So we help often articulate a specific problem that could show an impact. And with the innovation centers and all sorts of public funding bodies, because remember, the government is keen to push this area, I don't think companies need to invest much to start the process. But as I said, this is not one-off project. It should be part of the culture, So it could start from just simply talking to us, or just recruit a junior data scientist to start, with. So there's all sorts of things to start this journey, really.
And I guess related to that, and just listening to what you're saying, I think it's a very topical issue. A lot of people are probably thinking, maybe I should be learning a lot more about data science, and it might be something that people think about as a career choice now. And I think more and more companies are probably considering taking on data scientists, just as you've suggested. If you were an individual looking to get into this area, what would you recommend for that?
I lost the last bit, but I think I got your question, Sarah. You're absolutely right. I mean, we see this. I've been the course leader for the data science course for 2 years at our school. And we see people shifting career from engineering, from mathematics, from even statistics to be more into the data science. So there is all sorts of opportunities. One, I would always recommend look at online materials just to get an idea. But of course, formal education is very important. Here, for example, if I talk about RGU, we have the Masters in Data Science. And I think we have a great opportunity, the graduate apprenticeship, where, especially for those who are in full-time employment and they cannot commit full-time education. It's a great way to get into this area without much life disruption, if you like, So again, options are available there.
Yeah, definitely. And actually, the question related to that from one of the participants, Zubai, who's asked, do the School of Computer offer any short courses pertaining to data science?
Yes, I think there's few short courses advertised already on our pages, including cybersecurity, again, which is related, practical data science using R and Python. So there's a few short courses. I think some of them runs even up to 2 days or 1 day sometime, intensive short course. So yeah, definitely we do that as well.
I'm also aware that we're currently developing some new short courses in this area, which will be launched later this year. So if anyone that's listening is interested in that, then if you drop us a note through the knowledge bites at rgu.ac.uk, we'll keep you informed of them and let you know when they go live as well. So a question from Shupranil. AI helps to get rid of data accuracy and authenticity, but still it can give issues as it depends on machines. The question is how to get rid of that and keep the data accuracy and authenticity back up.
It's a very good question, and it's a big, it's a big area. I think, as maybe I put it in the first diagram, my experience, especially with real life projects, it is crucial to have the domain experts. If I'm working with oil and gas industry, definitely I need the oil and gas expert to be on board with me, when we look at the data and validate the results, and then perhaps grow up this accurately labeled data, But if you look at the bigger, picture, it's a very challenging problem. There's big players there. They control everything. Remember, what is authentic for somebody might be non-authentic for others, So, but yeah, I would say the domain expert is key part of the story, especially when we talk about real projects, really.
Mm-hmm. Yeah, I'm sure it was, because I was thinking when you were talking about the dogs and cats, and I thought, how do you determine that your data is authentic and hasn't been tampered with and
it's very tampering is very challenging problem. I have my former PhD student. She worked with me for 3 years. She's now currently an esteemed colleague at the School of Computing, Dr. Johnston. And this is a very challenging problem. Maybe detecting the bias in the data is easier. We can definitely detect and see, yeah, this data is discriminating against dogs, so we need to do something with it, but not with tampered content. It's possible, but it's more challenging.
Mm-hmm. And a question from Samantha. She said it was a great presentation. She's asking, what's the easiest way to explain the difference between machine learning and deep learning?
That's a very good question, and it could be very confusing. Look, people use deep learning, machine learning, and AI sometimes interchangeably. I like to think about it as two things. Machine learning, I like to refer to traditional approaches where we build our models, we handcraft our features, we train it, etc. I think the deep learning, although it was there perhaps before the 2000, I like to think about it more as the model that learns the features through the whole training process. So to give you an example, in the past when we used to do face recognition, you have to write some algorithms to detect the eyes, for example, of the corners, work out the distances between the eyes and the nose. We call these features, then you feed these into a classifier and you say, yeah, I have a face recognition system. With deep learning, because it's tried to mimic the way we think as humans, you just feed the whole image into a deep neural network. All these features will be learned by the model. It's not anymore handcrafted by you as a machine learning engineer. This is how I like to think about it, but definitely there is no right or wrong definition for these two terms.
Perfect, thank you. And a question relating to deep learning. And this is from Josie, what other areas of oil and gas do you think is ripe for automation using deep learning?
I think everything in the oil and gas needs to be automated in terms of AI and machine learning. And that's not me. I know people like working, for example, monitoring of equipments, pipeline monitoring, corrosion detection, defect recognition, sensory data which streams 24/7 on real time. I mean, probably 99.9% of the data coming related to the oil and gas is not intelligently utilized, So it's a huge area, and there is a lot to be really done in the oil and gas specifically.
Definitely, I would completely agree with that. A question from Scott. What do you think to the phrase, there's no such thing as a data scientist, due to the large area of study data science covers and how data scientist means much different things for different companies?
Scott, I don't know if I should answer this question because I might get fired, because we have a master's called Masters in Data Science. I totally, in a way, agree with you, but let me explain. You know, a guy from, I think, MIT graduated with a PhD in machine learning, and he went to a job. And in the interview, the guy told the boss, he said, you know, I'm looking for God. I want you to be able to download 10 gigabytes of data, run some pre-processing, fit a model, report the results, and interpret your findings to me in 3 hours or so. So he was looking for God. So that's the data scientist. It's a big term, but you know, when you work for years, yeah, could become an expert in the oil and gas and be a machine learning engineer at the same time, and perhaps you learn full stack development. It's a long process. You can't be a data scientist in 1 year, but you could start there. Yeah, I tend to agree with this.
But I guess it's a bit like, I don't know, I guess like engineering, that you could become, it's in certain fields that you will become a specialist.
That's true.
Or medicine.
And the reason why we call it, for example, data science, if I talk about our school, why we don't say machine learning course, because also we teach our students, I would say, the soft skills. They are able to communicate with business, help articulate a problem, and then prepare the data, and then train the models and report and communicate the results. Now, these set of skills way beyond just a software developer. So that's why, so it's more than a software developer, a machine learning engineer, I would say.
Yeah, great. So question from Daniel. I'm interested in NLP, and coming from a maths and stats and cognitive neuroscience background, could you talk about the future of this field and any recommendations?
Daniel, your background is the background I'm always looking for. When we advertise a job or advertise, for example, a scholarship or whatever, you know, NLP is a great field. And again, natural language processing, you know, I mentioned just one example, maybe in a very little details, you know. During the COVID, there is perhaps tens of thousands of research papers about viruses and SARS, etc. It wasn't possible for medical staff and emergency committees to sift through this. So they use NLP to summarize and extract the most relevant information of this large pile of data. Chatbots all about, you know, NLP. It's a great area, and there is too much to be done there. I would highly recommend and encourage you to go for it.
Yeah, sounds a really interesting background that he's got anyway. From Jackie, you say that 60 to 70% of the work on a project can be related to data preparation. Is that because the data quality is poor? If so, what can be done to make data quality better at the outset?
That's a very interesting question again, Jackie, and perhaps this relates to your first question, Sarah, about what the company can do. I think perhaps the easiest way is to make sure that your data that is stored is accurate and treated, you know, with respect at the first place, even if you don't do AI. But regardless of how good the data quality is, I think there is a still strong element of preparing the data to be fed into a machine learning algorithm or deep neural network. And in my experience, you still need to spend this amount of time to prepare the data, because practically speaking, Jackie, you know, fitting the machine learning algorithm is a few lines of code sometimes, you know. So really, I mean, our students, you know, they maybe the first or second class, they fit and evaluate the machine learning. It's already there, of course, the understanding. So the data is the crucial part.
Maybe a stupid question here, but coming from myself, would you have people that their job would be fully focused on preparing data?
That would be interesting. You know, although it is the most important part, usually in academia and sometimes in research, they refer to it as the dirty part of the work, you know. But we are talking here not about manual stuff. We were talking about like some really cutting edge methods to prepare the data, you know. But definitely as a data scientist or machine learning engineer, you will be aware of all these methods. You should be able to handle the missing values in the data, to suppress the noise, for example, to reduce the dimensions. All these are part of the life cycle data-driven project, if you like.
Mm-hmm. So this is important. A question from Glenn, and again, he's saying fantastic presentation. Very interesting point on cognitive bias. I've seen this firsthand, even in the latter stages of a machine learning project. Humans will at times revert to gut feel as opposed to looking at the output of the data. I'm not quite sure of the question there after having read that.
No, I totally agree with Glenn. Yeah, definitely.
Yeah,
well, we are humans. We are biased by nature. We love our own things and we rely on our own experience. And I usually just, to communicate this maybe clearer, I say the best cardiologist maybe on the planet, so don't know, 10,000, 20,000 patients in his entire career or her entire career. Today, you can train a machine learning algorithm using maybe millions of patient data and medical images and stuff. So it's the experience that matters, and the machine is not biased. The algorithm will never be biased toward his own experience. Of course, if you handle the data issue and stuff.
Yeah, I know. I don't think I'd be a very good data scientist. I'm always relying on my gut feel for
No, we all do. We don't rely on our guts. We all we have these feelings, and this is in one meeting with a friend who works heavily in the oil and gas industry. He said, "Yeah, I'm not gonna ever believe your AI models. I have a gut feelings and I know it works, And I don't think it's a gut feeling. It's the experience. It's the rich experience and knowledge they have,
That's true. There's a couple of other questions are still coming in, so we'll maybe if there's some I don't ask, we will answer them after the session because we are coming up to 3 o'clock. But just a couple of last ones for you, Iyad. Andre's asking, how important are programming skills in successful implementation of a machine learning project?
Andre, let me put it like this. 3 things I teach my daughter on a daily basis: programming, math, and English. Programming is a key skill. I think even if you're not a computer scientist or a data scientist or machine learning, learn to program. It's very important for machine learning, and for data science.
Great. And a question from Vimbek, I think. Sorry, apologies if I've said your name wrong. Thank you for an insightful presentation. Has there been any successful applications in the area of management of legacy data in the oil and gas industry?
There have been some really interesting work happening there. Unfortunately, usually we can't share everything when it comes to collaborative projects because there are elements that we need to protect our partners' interest. But definitely, there was very interesting stories about taking a pile of thousands of heavy text reports and get really insightful stuff out of it.
Mm-hmm. I know from my past experience, I was involved with decommissioning, and the big challenge about when coming to decommission platforms is knowing what's actually out there, because a lot of the information is maybe lost or paper formats rather
That's
than
very true.
So,
and according to oil and gas people, I don't know if I can reveal the name, but 30% of the time spent on looking for the actual information, just finding the information, That's why the oil and gas, they are very active now, and they want to push and transform really this practice.
Yeah, no, I think, and there's been a couple of other questions about how other opportunities in oil and gas, which you've covered, but I think what you've said, there's just huge opportunities, and I know we have a number of people on the line that come from the oil and gas sector.
Yeah.
But it's applicable across all sectors.
Yeah, definitely.
Yeah. Okay, perfect. Yeah, I think we'll come to a close now. And for those that I haven't been able to ask questions to yet, we will get back to you on that.
Sure. Please feel free to contact us anytime. We like to share. We are here at the School of Computing to share knowledge and promote our, this research area, which is very important, as I said, to all industries. Thank you all.
Oh, and thank you very much, Ziad, and thank you everyone who's joined us today, and thank you for the great questions. It's led us to quite an interesting discussion, and I've certainly learned a lot this afternoon. So just as I said before, the recording of today's webinar will be available on the RGE Knowledge Bites for Business webpage as of next week. If you do have any further questions for Ziad, or any other questions about the university, or if you have any other topics that you'd like us to cover in future Knowledge Bites for Business webinar, please get in touch through the knowledge bites at rgu.ac.uk. We'd love to hear from you. And otherwise, I hope you all enjoy the rest of your day, and thank you very much again.
Thank you.